So what we're looking at here is all of the 9 different types of SysML diagrams that exist. And we're trying to focus this video on the block definition diagram. We'll be explaining all of the different types of elements, such as the block, the class, and specific types of blocks, as well as the relationships, such as the directed association, directed aggregation, directed composition, and the generalization relationship. We will talk about how the block definition diagram connects to other diagrams within SysML, and we'll give multiple examples. So first, for a couple of definitions for reference, we have the block, which is a modular unit of structure. We have the block definition diagram, which is the SysML diagram type, which blocks are shown on. And we have the definitions for each of these below, and an example from our SysML user guide, which you can look at by going up to the help within your Cameo toolbar up top. Next, we'll look at the different types of properties which can be associated with the block. We have the reference property, the part property, and the value property. This is what it looks like in the containment tree. You have the little icons R, V, and P for reference, value, and part. You can pull these out if you'd like and show them like this. Going to our composition relationship, this is our whole part relationship. We have some definitions explaining multiplicity on both sides, and we have examples here of 3 different ways to show the same exact breakdown. We have the aggregation and association relationships that both create reference properties. The definition and when to use a reference property is shown up here. Our directed aggregation relationship has the open-ended diamond. The association relationship has no diamond at all. Our generalization relationship is shown down here. You can have a generalization relationship between many types of elements. Our examples are block, signal, and value type. The way that you explain this is dog is a type of pet, visible light is a type of light, distance is a type of real value. So down here on the bottom, you're going to have your specific classifier, and up top is your general classifier. When you create a generalization relationship, you will inherently create inheritance, where the dog will inherit everything that is within the pet block. So with that, we'll go ahead and get started with our examples. Our first example is the diagram that you're seeing here. It's kind of a meta example. So we know that it's a block definition diagram because you can look at the top left diagram frame and see BDD, which stands for block definition diagram. We can look and see generalization relationships throughout this diagram, and you create those relationships by just clicking on the generalization button and then selecting where it's coming from and where it's going to. So what these generalization relationships are saying is that the parametric diagram is a special type of internal block diagram. The internal block diagram is a special type of structural diagram. So what we're learning is that the block definition diagram is a special type of structural diagram, which is a special type of SysML diagram. So this balloon example is going to help us explain some of the relationships that we've just talked about. This right here is the generalization relationship. So it goes from specific classifier to general classifier. So we can say that balloon animal is a type of balloon. Weather balloon is a type of balloon. We have value properties that you can see in the containment tree here as well, that are properties of the balloon. And then all of these properties have been inherited by these specific classifiers. So if you go to Macy's Day Parade balloon, you go to properties, you can see these inherited values, and then you can redefine them. You can redefine them and add in different values, and it will say redefines volume from the general classifier. Now looking at the breakdown of the hot air balloon, we have our system block and our subsystem blocks. These are special types of block that we can find by clicking this down arrow for the domain, and you can see system and subsystem and system, as well as some other ones, and you can just click them and add them to the screen. So to expand on this, we're just going to create a new package and just call it block generalization. And this is going on in the background of SysML. So this comes out of the box. So we have a block and we have specific types of blocks. And then what we'll do here is I'm going to show the most abstract entity, which is called class. So I'm going to actually refactor this, convert to, and then just class. So this is I'm just going to name it what it is, class, and then this is a block, and then this is a special block 1, and you'll see the generalization relationships which appear. So if I just click on these and display all in between paths, it says nothing to display. So I was expecting it to show generalization relationships like this, because system context block is a special type of block and a block is a special type of class. So the way to actually see that relationship is you can go down by turning on your show auxiliary resources and going down to SysML profile, and you can look within these special types right here, and this generalization relationship between the domain block and the block, that is essentially this generalization relationship here. So, and then you can also go to the block as well, which I'll try to do right now, block of class, and you'll see if you look inside at the specification window, the meta class right here is that class that we made up here. So, and then also you can see the documentation for the block itself, which explains what the block is in great detail. So that can be really helpful when you're looking at other blocks. You can actually use the SysML profile to understand how everything is put together. So for example, we're learning that the superclass is a type of block. So domain is a type of block. That's what it's saying there. It has that generalization relationship from domain to block, which makes block the superclass. And then the meta class is a type of class, which is this. So it's 2 hops away. And then we've got documentation on each of the entities. So very helpful to know that you don't have to go into your help and documentation, even though this is a helpful resource as well. You've got hundreds of pages of information to pull from here. You don't have to do that. You can just go down to your SysML profile and kind of sift through that to understand. Now back to your balloon example. One quick thing is if your blocks are all stuck on one line and you may want to have them go to 2 lines or more lines, what you can do is just click on the block, go to your symbol properties and type in word wrap, or just wrap words. And if I set this to false, it will force it on 1 line. If you set it to true, it will allow you to make them go to 2 lines. So that's helpful. What we've got here is we've got directed composition relationships. We have this type of relationship. So we have the diamond that's filled in on this side and the arrow on the other side. And what that will do for us is it will create part properties. So if I delete this one from the model, it is gone and there's no part properties. And then if I add the directed composition, you can see it added back, and you can change the name of this and it will change it in the containment tree down here. So that is a parent-child relationship. So all of these will make up the hot air balloon, basket, parachute, burner system. Right now they have no multiplicities applied to them. Multiplicity can be seen right here. So roll of the hot air balloon is up here. Roll of the basket would be down here. So a hot air balloon, if it's unspecified, defaults to 1. What that means is the hot air balloon has 1 basket. And you can do different multiplicities for different items. So it's going to have 1 parachute and 1 burner system as well. But maybe if you added people, you could have, 1 to many people. And the way that you would do that, so I'll just add people. And click on this and then do 1 to many. And that's what the asterisk is. But realistically you can't have infinity numbers, so you'd say like 1 to 6, for example. So that's how many people could be in the hot air balloon system. And that's what multiplicity means. So the next thing is just normal composition. So I'll go ahead and delete that from the model, and we'll stick with this basket. So if I'm going to create just a normal directed or just a normal composition, the difference is that there's no arrow down on this side. So we still have that part property that's made, but we also have a reference property that's made from the basket side. So if we look at that, you can see the part property is made on the hot air balloon side. So I'll do the basket 456, and you'll see it right there. So that created the part property, but also if I hit this plus, I have the reference property that is created on the basket side. So if I do hot air balloon ABC, you can see that, and that is just not very useful most of the time. So I would always fall back on using the directed relationships versus the non-directed relationships. Getting into why is an advanced topic, so we won't cover that here, but I would always use directed relationships. And we also have associations. So this is the same sort of concept. If you have the arrow, then so we have one reference property which has been created here between basket and parachute. So if we go to basket, we see the reference property of parachute, but if we go to parachute, we don't see the reference property to basket. And so if I go ahead and delete that relationship and instead just use a normal association, so there's no arrows, you still see them on both sides. We got parachute, that's a reference property of basket, and then we got basket, which is a reference property of parachute. So this is a weak relationship type. I try to stay away from associations as much as possible, and stick with aggregations or compositions. Compositions are what you're seeing here. Aggregations, the directed aggregation relationship can be created to the fuel block, the fuel that is used within the hot air balloon. And we've got a whole other video to explain when to use the directed aggregation versus directed composition. I would fall back on using the directed composition. So I'll go ahead and add a directed association back between basket and parachute, and we'll just name this parachute ABC, and then we're going to run this in simulation so that we can see all of our different types of relationships. Before we do that, we go down here and see the other relationships that are going on behind the scenes for the hot air balloon. See the caret, that means it is inherited. And if we remember, that is inherited from our original balloon block up here. So now I just showed the inherited value properties. So when I run this in simulation, you can see the different properties that we have under the hot air balloon. We have the value properties that you see with the V icon. You have the part properties that you see with the P icon and the R for reference property. And then you can expand that and you can see that parachute 1, 2, 3 is nested within the basket. So we haven't filled out any of these values, so we can do that as we please. Like that. And if we wanted to, we could export this to a new instance within our model, and that would create a hot air balloon instance, and then we could show that in an instance table. And this is just a way so the classifier would be balloon, and the scope would be the balloon package, and you can see that what we've added here. So if I wanted to change some settings and just do like that, I could export this to a new instance and again just put it in my balloons folder, and you can see it here. So you can show many different types of instances with different classifiers. So I don't have to have a hot air balloon. I could do something else like a party balloon. So I could run this in simulation, and I'm just making things up here. Export that. Oh, export to a new instance. And you see it here, you see the classifier is party balloon. So any of the balloon types, because the classifier is balloon, would be able to be in this table. Now we'll explain the difference between part properties and blocks, elements of usage versus elements of definition. So what we're seeing here is our block definition diagram has a bunch of blocks on it with these connections between blocks, which are directed composition relationships. The blocks themselves are going to be elements of definition. The relationships between here, the directed composition, when you have this relationship, it actually creates a part property, which is an element of usage. And on your internal block diagram, your IBD, you will always see elements of usage. You will not see blocks on an internal block diagram. You will see part properties. So if you go over here to NASCAR, you can see left front, left rear, right rear. These are all part properties that you see on the internal block diagram. Left front, right rear, left rear. So they're all wheels, which is your reusable block or element of definition. Elements of definition are reusable, and then part properties are the usage of that reusable element. So you can see your part properties in your containment tree: left front, left rear, right rear, and they're all of type wheel. In this example, we've got lots of specific types of pets, and then we've got our generic pet blocks. So these are our specific classifiers, and this is our classifier. So we'd like to create generalization relationships from the specific to the general, like this. I can do it like that, or I can do them all together by just selecting all these, right-clicking, create their relation, outgoing, and then type in generalization, and then you just select where you want it to go to. So they were created. It says it down here in the right, bottom right, and then you can right-click, display all in between or all paths, and then you see all the relationships have been made, and you can just pull down and see that in the containment tree as well. So the next thing you'd want to do is, I normally have a secondary block called, it can call it whatever you want to. In this case, we've called it pet qualities. So we've added value properties for all of the things that could describe pet. So a pet could have a name, a weight, a speed, a lifespan, and a yearly food cost, for example. Now, none of these value properties are typed this time, but you could do that by just typing it in like that, or you can hit this T right here and just search for your value property that you want to search by. So now what's happened is we want to add these value properties to the pet and to all of our specific classifiers, our frog, our horse, our rabbit. So right now, if I look into rabbit and go into attributes, you see nothing because there's not that connection made. But if I make this generalization relationship for pet qualities, now what's going to happen is these value properties will be inherited by pet, and then the frog will inherit the pet's value properties. So if I go into frog attributes, you see the attributes there. And you can scale this as well to make it go down a level. For example, we're going to just go ahead and create another block definition diagram. And we'll say that our dog is our generic classifier here. And our specific classifiers are just going to be from this notepad. We could have that from Excel or Word, but I just copied it, Control C, I just do Control V. I say you want to paste it as a block, and you've got all of your different dog breeds here. Then I can just drag them on the screen, and again, right click, create relation, outgoing, generalization to here, and then display in between paths, and you've got it. And if you look into the golden retriever, you'll be able to see in attributes that it also inherits those pet qualities. In this example, we've got our iPhone 14 Pro Max, and we've broken it down into its subcomponents: battery, screen, processor, frame, and case. Case has a multiplicity of 0 to 1, meaning it's optional. You don't have to have the case on the iPhone. And we have this hardware block, which is connected via generalization relationship to all of the subsystems and the system level. So we're saying that each one of these subsystems are going to have a mass and a material associated with it, or we can prescribe that. We haven't redefined anything except for this high level mass value. Then we've got the iPhone weight requirement that we went ahead and added, and we have the satisfy link between the total mass of the iPhone and the requirement. So what we can do is we can push play on simulation, and we see that the requirement has been satisfied. 8.47 is less than 10 ounces, so it's satisfied. You can go in and force it to be something like 11, and you'll see that it turns red and shows that it's not satisfied. So that's nice. So now you have an option. You can either build out the parametric diagram aspect of it. So you would right click, create diagram, and then create a parametric diagram. This would allow you to do like a mass roll-up, where you could say the mass of the battery plus the mass of the screen plus all the other masses will equal the total mass. So it would actually calculate this 8.47 value as opposed to just inputting it in there. Or you could just do an internal block diagram. So you could go to create diagram, IBD. So this internal block diagram, you would just see all of the part properties. We'll just go ahead and remove the value properties. And then you can start to create connections between the processor and the screen, and the frame, and then the battery and the processor, and then the case and the frame. So, and then you will later go back and explain in more detail, what type of port this battery is sending, voltage from the battery to the processor, and you can prescribe exactly what's going over that connector, and you can say what signal is going over it and all that. The intent is not to explain the IBD, it's just to explain what path forward. The IBD is another structural, it's the internal structure and how part properties are connected, and so you could do that. The other option is so now you've got this icon right here, and you can double click and it will go to that, since we only have this internal block diagram. So I'm going to delete that now, and we could also go the other route. Instead of making another structural diagram, we could create a behavioral diagram. So we could have either a state machine or an activity diagram. And both of these are perfectly fine to make. I'll just go ahead and make a super easy one. So it's just like turn on and then run. Obviously this is oversimplifying it, and so now that you've got these actions in here, we can run this in simulation. We have two options. We can run, or we can run with context. And so the big thing to remember is that if you've got this activity underneath the iPhone block, then you'll be able to run them together. The classifier behavior of the iPhone 14 Pro Max block is this activity. So this is saying that they're linked. So when you run them with context, run with context it means run the activity with the block associated. That's why it has a little block icon there. So you see that it's actually pulling these value properties and such from the iPhone block. Now when I push play, it's actually going to run the activity itself like that. Now it's done. So why would you want to connect them? The reason is if you have value properties that you want to change over time, you can do that. So if, let's say, the battery percentage goes down over time, you could have a block in here, opaque action, which is kind of out of the scope of this video, but you could say that your battery percentage equals battery percentage -1 or something. So you could have math in this loop somewhere, and then if you had the create diagram, create element, value property, and I'll just add a battery percentage equals 100 of type real. And I'll just go ahead and get this to loop. So it's just going to do it forever. I'm not going to have an end. So now when I run this with context and I click run, see it subtracts. The battery percentage is now just going down. So if you didn't have those connected, it would actually fail. So if I stop this and instead of running with context, I'll just run and I push play. See how it just failed right there? If I go to my console, it says execution is terminated. There's an error. Battery percentage is not defined. So you have to run it with context in order for it to work. I'll run it without the context again, and you'll see cannot evaluate opaque action. So that's why you want to connect them. Going back to our iPhone BDD, we can look at these blocks in different ways. So if I've just clicked delete here, it doesn't delete it from the model, it just puts it in a different view. So this is another view where you can see the parts in your parent block all together, and this is totally okay to do. Nothing has changed. So like this and this are exactly the same. And then you can also go to these dots up here and just toggle what you're seeing. So you can change that as well. You can also go to edit compartments and add specific compartments. So if I go to, I can add the documentation, for example. I'll do that. Since there's no documentation, I'll add some. Added documentation, and you see that it's added to there. We also have the ability to add rollup patterns. So if we go to right click, go to tools, apply rollup pattern. You can add a cost rollup pattern, mass rollup pattern, or power rollup pattern. These come out of the box. You can also create your own rollup pattern. We'll go ahead and add a cost rollup pattern and keep these apply recursively and set subsetted properties. Click OK. You see that a bunch of subset subcost happens. So now when I run this in simulation and I show the variables, I have this total cost right here. And what that means is that behind the scenes, if I go in and change the cost to, it will add up accordingly. Just making up these values off the top of my head, but you see that your total cost adds up everything, and it's really nice and easy. Now I caution that while this is nice and easy for a small example, it can get kind of confusing once you scale this out to an entire system, because you can't actually see what's going on in this rollup pattern. Like there's no diagram for it. So I would just be careful with this. There's some caveats. So I can take that, and then I can also say I don't want it. I can remove the rollup pattern, and I can say that I want to remove that cost rollup pattern, and now it's gone. So if I run this again, you don't see any of the cost values associated. So kind of a nice feature. Another two special types of blocks that I think are worth talking about are the interface block and the constraint block. The interface block types proxy ports, so I can also show proxy ports on your BDD diagram. I generally don't find this very helpful, but so we can make the charger port, and what we'll do is we'll call this the lightning adapter, and then I would just drag this over here, and you see that the charger is typed by the lightning adapter. Now the constraint block is used for parametrics, so it can be any constraint, be an equation. So we'll just do a sum. I've got several sums, so we'll just go ahead and make a new one, and then you can add your math in here. So the parent equals the sum of the child, and then you can click this parse and create parameters, and it will automatically do that for you. And then you can see that over here in the containment tree. So these can also be shown on the BDD, and then you can apply this constraint to the iPhone Pro Max like that, and then you're going to have to create your mapping between the children and the parent. So the parent would be the iPhone value property such as mass or cost or whatever you're summing. And then the child would be each of these value properties that you're trying to sum. So you have to create a parametric diagram to complete this. But to do that, you would just create diagram, parametric diagram, and then I would show all of my part properties. Like this. So this is the constraint we just added. And these links were created from our IVD that we created earlier. And then what we're talking about is that the parent would be connected to, let's just say we're adding up mass. So some mass, for example. And then our children, it would just take all of these right here like this. And you can connect them all to that one child block, and it work appropriately if you go to properties and specify that the multiplicity is many. So now when I run this, it will add, and now the mass is greater than 14, and it will show this on your screen as well. And because it's not meeting the requirement, it fails. If you made it this far in the video, go ahead and give us a comment about something you liked or want to see in the future. We try really hard to make good content for you guys. Thanks.